Welcome to the deep dive. We've got some fascinating sources you've shared, and today, well, we're tackling a big one. Consciousness.
Yeah, a huge one.
We're looking right at that edge, where classical physics seems to sort of falter.
And quantum mechanics steps in with some pretty provocative ideas.
Right. So our mission today is really to pull out the key stuff from these sources, explore this idea of the unseen battle for the imagination.
Exactly. And that battle, it's really about trying to square the objective world, what science describes, with, well, our own subjective experience, which is undeniable, right?
Totally. Okay, so let's start there. Why isn't classical physics enough? I mean, the brain is complex, sure, but isn't it basically a machine?
Well, that's the crux of the hard problem, isn't it? Classical physics, it's great for the mechanics, how neurons fire signals, all that processing. But it hits a wall. It just can't explain why any of that feels like anything.
The actual feeling, like seeing red.
Exactly. The redness of red, the taste of coffee, that what it's like feeling of being you, qualia, they call it. And what's weird is how attention seems to affect them, almost like a quantum measurement kind of thing.
Okay, so that difficulty, that's the opening for quantum ideas, like this quantum-like qualia or QQ hypothesis.
Precisely. The core idea there is maybe qualia themselves act like quantum observables.
Meaning?
Meaning, before you focus your attention, your experience might be sort of indeterminate, fuzzy. It only clicks into a definite state when you measure it internally.
With attention or sensory input.
Yeah. And they think this isn't just navel gazing. It could predict actual effects you can test. Like, does the order you notice things change the experience itself?
Wow. That's wild. The feeling itself having quantum properties.
It is.
And then there's ORCHRS, orchestrated objective reduction. That's another big one from the sources.
Yes, the Penrose-Hameroff theory. This one zooms right into the neurons, into tiny protein structures called microtubules. The idea is that consciousness arises from quantum vibrations happening there. These microtubules have electron clouds, places where quantum effects might, take hold.
Any anesthesia link.
Right. Anesthetics seem to bind right there on the microtubules. The thinking is they might disrupt those crucial quantum vibrations. And Penrose brings in his objective reduction idea, a type of quantum collapse not caused by us looking, but by, well, space-time geometry itself. It's non-computable, he argues.
So consciousness isn't just a calculation.
That's the implication, not purely algorithmic.
So we've got quantum effects inside neurons. What about ideas suggesting consciousness is maybe even bigger, not just stuck in brains?
Right, that brings us towards things like panpsychism. The notion that consciousness, or maybe some proto-version of it, is fundamental, like charge or spin, part of the universe's basic toolkit.
Not just an emergent thing from complexity.
Potentially not just that. And related are quantum field models, the idea of a universal consciousness field, sometimes called the F field.
A field for consciousness itself.
Yeah. And what's interesting there is the link to computational density, how much processing and connection is happening in the system.
So more density, maybe more consciousness.
That's the idea, which, opens a pretty big door. Could AI become conscious if it hits a certain density threshold?
Whoa, okay, that's a huge thought. But hang on, all these quantum ideas, they rely on delicate states, right? And the brain is messy.
Absolutely. That's the elephant in the room, the warm, noisy brain problem. It's the main criticism.
Because quantum coherence is so fragile.
Incredibly fragile. Critics say in a warm, wet brain, any quantum coherence should vanish almost instantly. Decoherence, it's called.
Yeah.
Way too fast for complex thought.
So how do proponents counter that?
Well, it pushes research into how biology might have sort of evolved ways to shield or manage these quantum states. It's a very active area.
Okay, so stepping back, what are the bigger implications here for things like, say, free will?
Well, if reality has genuine randomness or indeterminacy at its quantum foundations, that potentially breaks strict classical determinism.
Create some wiggle room.
Exactly. Maybe room for actual choice, emerging from those quantum probabilities.
Yeah.
Maybe intention itself is like exploring quantum possibilities before settling. An entanglement thing.
And the observer. We're not talking about collapsing waves out in the world just by looking.
No, not really that old interpretation. It's shifted more towards thinking maybe consciousness itself uses a collapse-like process, but internally.
How so?
Like when you decide something or form a clear perception, you're taking this fuzzy space of mental possibilities and collapsing it into a definite thought or feeling in your own mind.
Interesting. What about altered states? Psychedelics, meditation, how do they fit?
Some models use that reducing valve idea, like our normal consciousness filters a much broader reality.
And altered states loosen the filter.
Maybe. Allowing access to, wider fields of information, maybe tapping into something more universal. Concepts like holographic resonance get mentioned sometimes.
It sounds incredibly difficult to test any of this stuff experimentally.
Oh, it is. Hugely challenging. But people were trying. You see things like looking for specific vibrations in microtubules with special tech.
Like T spectroscopy.
Yeah, things like that. Trying to link brain scans, EEG or fMRI, to predictions from these theories.
Yeah.
Even speculative stuff like trying to entangle a brain with a quantum computer. Or controversial tests looking for tiny mental effects on random quantum noise.
Wow. Okay. So, wrapping this deep dive up, it really feels like consciousness might be far more tangled up with the universe's basic rules than classical physics allows.
That's the picture emerging from these sources, yeah.
Yeah.
From qualia acting weirdly quantum-like to these universal fields, even the potential for AI consciousness tied to processing density. It's definitely pushing boundaries.
And that warm, noisy brain problem is still a huge hurdle.
Absolutely. But it's driving really fascinating science, trying to figure out if biology has quantum tricks up its sleeve. This whole unseen battle for the imagination, it's ongoing. It's about understanding ourselves in what could be a profoundly interconnected, maybe quantum reality.
So here's a final thought for you to chew on. If consciousness, your own subjective awareness, your you-ness, isn't just confined to your skull, but is linked to space-time itself or part of a universal field, does that change what it means to be you?